Hello learners, this is Sir Knight, and for this week, I'm going to teach you about statistics and probability, random variables, and probability distribution. To start, let's have this first table, defective cell phones. The first column is what we call the possible outcomes, or the sample space. The sample space is the set of all possible outcomes of an experiment. Therefore, defective cell phones is an experiment, and the possible outcomes of it are DDD, DDN, DND, NDD, DNN, NDN, NND, and NNN. The second column is what we call the random variable X. Random variable is the function that associates a real number to each element in the sample space. Therefore, if we are going to denote random variable X as the number of defective cell phones, capital letter D, the random variable of the first possible outcome is 3, and then 2, 2, 2, 1, 1, 1, and 0. These random variables are also called discrete random variable if the set of possible outcomes is countable. Since our experiment is defective cell phones, therefore, this is an example of discrete random variable because it is countable. In addition for that, we also have the continuous random variable, which is the opposite of discrete random variable if the values are on a continuous scale such as heights, weights, and temperatures, or anything that can be measured. To continue, let's now have the second table. This is what we call the discrete probability distribution. When we say the discrete probability distribution, the probability mass function consists of the values a random variable can assume and the corresponding probabilities of the values. In other words, we are getting the probabilities of each random variable. Let's have this table as the discrete probability distribution of defective cell phones. The first column is what we call again the random variable X, defective cell phones. In our previous table, we can see that we have only 4 real numbers, and these are 0, 1, 2, and 3. And to get the probability P of X, which is the second column of each random variable, we are going to count the random variable in our previous table, and then we are going to divide it by the number of possible outcomes. How many possible outcomes are there in our previous table? The answer is 8. Therefore, for our random variable 0, the probability is 1 over 8 or 0.1250. For our random variable 1, since there are 3 ones in our previous table, the probability is 3 over 8 is equivalent to 0.3750, and the random variable 2, the same as the random variable 1, the probability is 3 over 8 is equivalent to 0.3750. And lastly, the random variable 3, since this is the same as the random variable 0, the probability is 1 over 8 is equivalent to 0.1250, and the total of the probability is 8 over 8 is equal to 1.000. Applying the properties of discrete probability distribution, we have 2. The first one is applying the first property of probability distribution, which is the probability of each value of the random variable must be between or equal to 0 and 1. As you notice, the probability is 1 over 8, which is 0.1250, and the probability 3 over 8, which is 0.3750, are all between 0 and 1. Applying the second property of probability distribution, which is the sum of the probabilities of all values of the random variable must be equal to 1. As you notice again, if we are going to add all the probabilities, 1 over 8, 3 over 8, 3 over 8, and 1 over 8, the equivalent is 8 over 8, and that is 1.000. Even you add the decimal probabilities, the equivalent is still 1. That's it. This is Sir Knight, and remember that ang batang matyaga ay batang matagumpay.